So here's Sigma Studio. I opened it up and it's obviously a blank screen. So let's start with a brand new project. Go over to the far left, you'll see new project. Actually, if I clicked here, then get new project, and boom. What opens up is a palette here in the tree toolbox. I should mention the toolboxes. There are two toolboxes, easy for me to say, right here. I usually use the tree toolbox. I find it's the most useful ones because things are kind of sorted. But the other one is fine. It's all what you kind of get used to. And then the capture window, it's a good idea to have that on here in the bottom. We'll talk about that more later. But otherwise, this should come up on as a default. But if not, that's how you turn it on. Tree toolbox. I'm going to shut this off, see it goes away, and it comes back. Now, what we have here is a list of processors. And some of these are just codecs that we can drag into a project. And then there's things called communications channels. So for communications channels, right now we're going to use the USB-I. And that's at the moment, the only one you should use for a while. We'll drag that. I click and drag that in, and boom, it's in the project. There's the USB-I. It is green because it is plugged in. If I unplug it, you're going to see it turns red, or I guess red. It's kind of an orange. And that tells you there's no connection. So that's the first little troubleshooting tool there. Okay, now let's find a 1701. ADAU1701 right there. And we'll drag one of those in. It loads a few things in, and then we make the connections for communications. Now we're connected. It's going to default to I2C because these eval boards are I2C. This one is. You can change it if your hardware needs SPI. There's the SPI settings, or if you're on if you have multiple DSPs and you're on different address lines, you can address different DSPs. You can drag in more than one and set them up to different addresses, and you can have two. You can be programming for two devices at one time. It's kind of handy. So anyhow, we got the 1701 in there. Now we're ready to go. What we have here, while we're still in the hardware configuration tab, see the sub tab here, config, we can go over to register controls, and here's all our register controls. Let me pull this down a little bit. This part is pretty simple. There's not a lot to it for registers. So this is it. This is all of it. I don't necessarily recommend going read all, because if you're having a communications issue, it can literally reset every single register. This DSP is not as huge of a deal, but other ones it can be. So we go over to the schematic tab on the top. And here's where we're going to set up our schematic. So let's do our... Oh, today what I'm going to do, by the way, is what I call my basic input-output oscillator project. It's a project that I set up and use a lot because it has all the basic things you generally need to do something. And I found myself constantly redoing this over and over and over. So I just finally set up myself a project where I just load this project first, and then I add in the cells I want to, for whatever I'm trying to do audio-wise. So this is a good one to save in your folder as a starting point. Alrighty, so the 1701 comes up here, and here are the tools, the library for the 1701. And we want to start, of course, with input. So let's go to I/O. We have an input object. Drag that input object in, and there you go. There's only one input object in this part. The first two are the ADCs. So 0 and 1 on this are the two ADC inputs. The rest, which aren't enabled at the moment, well, all I have to do is click on it to enable it, is labeled 2 through 9. But those are the 8 digital inputs for the serial digital port, the I2S port or the TDM port. It'll do up to TDM8, so you have 8 different inputs, or it'll do 4 stereo I2S lines. in, and this is where they would appear. That audio would appear. So this is the audio coming in from the ADC, and let's start doing something with it here. Let's just go to, how about to a volume control and add a volume control. So volume controls, adjustable gain, single. No, let's go to the shared. I want the software, the single software slew volume control. So this volume control has what's called a slew. That's what this number is in here, meaning when you make a change, it'll slowly step in very, very small steps to reach your final target volume with an RC curve, and make a much more smoother, with no zipper noise, volume change. So it's a good thing to have. Now, okay, I'm going to go hook up the left channel, and now, wait a minute, I want to hook up the right channel. I could always drag or copy and paste one of these, but I'd rather have just one control. So what you do is you, on the bottom, near the bottom of the GUI here, right click, and it's going to come up with a menu, grow. So we're going to grow this by one. We're going to add one. It doesn't mean it's going to be one channel here or two channels. It's add one or add two. So we're going to add one more channel. So voila, we got stereo. And let's hook this up there. And let's go to the, well, I would say go to the output, but it'd be kind of nice to have some meters. So let's put some meters in, because I want to see if something's coming in. So let's go to level detectors and lookup tables. You see right there. And level detectors, single band would be fine. And my favorite one here is the one, it's the newest one in the library, with numerical display. I like that one because it'll tell you how many dB the signal is. Now, I need to copy this. This you can't grow. This one, there's no, you can just remove the algorithm, but you can't grow it. So I need two volume controls to get two volume controls for both channels. I could copy and paste. That would work. But I also can do a trick, which you hold down the control key, click and drag, and you make a copy of it. Good little shortcut there. Anyways, moving on, we make the wire connections. We're connecting wires. We're soldering, so to speak. Okay, now let's get some output. Go to the output cells. These output cells are a little different from the input cells. It's just they're single ones, and you select the four DACs, one of the four DACs, 0 through 3, or the digital outputs, Digi 0 through 7, for the 8 digital output channels. But we want two channels, so this time I'm going to do a copy and paste. Control C, Control V. I'll talk out what I'm doing here. Now, it automatically assigned numbers, DAC 0, DAC 1. But remember, this eval board has the Class D amplifier on 0 and 1. So we want to put this actually out on 2 and 3 if we're going to hear it. And then we connect to it, and we should be in. Now, we have been in what's called design mode. Look down on the far right of the screen. This is an important area to keep an eye out. Far right bottom corner there. It says design mode because we've been working, creating the design. It's not active. It's not downloaded to the DSP yet. Oh, I should turn on a picture of the DSP so you can see the DSP going. See, there's the DSP. Ta-da. It's not there yet. Not that we're going to really notice much in a minute. But anyhow, so how to download it, how to compile, link, and download this project. Those buttons are all up here. Oops, I got to go on this screen. Sorry. They're all up here. Link project, link, compile, connect. That's a whole nother discussion. Then link, compile, download. That's what you're going to use the majority of the time, is link, compile, download. So let's load this down to the DSP. Click. Boom. Look on the bottom right. It says active downloaded. So now the program is running in the DSP. It's not running in the host computer here. It's running in the DSP, and we can control it and watch it. I'm going to turn this volume down a little bit to start with, and let's turn up the meters. Gosh, there's some audio looking. Well, we'll talk about that in a minute. Let me go over to my other computer that tended to go to sleep here, and let's play some music. And we're hearing music. And we're seeing it on the meters. There, and stop. Okay, so problem number one is I hit stop, but look, the meter's still awfully high. Is that noise? Well, no, I'm not hearing noise out of the speaker. So what it is the DC offset out of the ADCs. On this part, there's no high-pass filter in the ADC. They assume you just do it in a DSP. Most codecs will have a high-pass filter setting in the ADC. I recommend you select that in your options. When you're dealing with a codec or an external ADC, turn on the high-pass filter. It's free processing. It's generally a corner frequency of like less than 1 hertz or less than 3, so generally it's not a problem for your audio bandwidth. So in this case, we have to deal with it here. I mean, it's fine going out, but if I start EQing the low end, it's going to EQ up that DC. If I start switching between signals, you might get pops. So we want to get rid of it. So I recommend on this particular Sigma DSP, you go to the filters section, and then there's one called miscellaneous. And in here, you're going to see DC blocking. See what the name of it is? DC blocking filter. So we're going to drag that in. I'm going to do my control trick and double that. So we have one for each channel. You could also grow. Yeah, I think I could actually add another one. But for the moment, I'll keep it as separate. And so now I'm going to move this. If you highlight the wire, you can grab the end and drag it up there. See, which is not that it's that hard to redo it, but if the line goes really far, it's great to just be able to edit the one end of it. So we have the DC block. Now see, once I started adding things in, we went back to design mode on the bottom right, and nothing's happening here. I wouldn't be able to change anything. So, but the program's still running in the DSP. I can still play music, but we have no control over it. And it's the old program. So let me reload this new one. So link, compile, download. And boom, look at the meters. Now it's down to the noise floor of my computer. And if I hit off, will it actually go off more? No, it's just the noise floor of this other computer. So, but now we're good. Ta-da. On these objects, by the way, if you go up into the middle of them, you can right-click and you can change the range of the meter, the min and max, and well, units. And they likewise down here, I clicked and I got reduce or grow algorithms. But if I go up here and right-click, I can set the value. I can set with the max and the min because these can have gain. Because we'll talk about this more in another video, but these DSPs, the audio comes in 24-bit, but on this particular one, in the core, it's 28 bits, and it adds 4 bits on the top for headroom. Well, 5, you get the sign bit, but anyways, so it gives you more headroom in the DSP. So we actually can get some more gain out of it if you wanted to. Seems odd to go over 0 dB, but in the DSP 0 dB FS, we're generally talking about the serial ports into and out of the core being 0 dB FS to 24-bit, and then in the core, we're still calling it 0 dB FS, although technically it's not. But you need to get back to that reference level, so it's good to call it that and know that you have gain above it, headroom above it. So anyhow, pretty cool. We're pretty far along my basic project, by the way, and what I want to do. Now, for testing purposes, because you don't always have a good audio source, and if you know, if I got nothing here, if I hit play and I got nothing, I do have the meters. That helps. I can see, well, yeah, there's something coming in. Uh, but what I also like to be able to do is generate a signal from inside the DSP. So let's do that because we can then test from inside the DSP out. Especially handy for serial digital because you can check the level with a known level. So anyhow, let's do that. If we go to the sources, we have many different kind of sources we can add. So we'll go to oscillators, and then again a bunch of different oscillators, but sine tone. So we'll add a sine oscillator, sine wave oscillator, and we got to hook this up. We'd like to be able to switch between the two, so we need a switch. Well, okay, do we have a switch? Yeah, we do. It's called a mux. Mux or demux are switches. So a multiplexer, and then here it starts being called a switch. Index selectable, that's for another topic. We'll do the no slew kind because we don't care if it makes a little click when we switch it. And we need two channels because we're dealing with stereo. So let's drag in this stereo switch. There it is. And I'll hook up these outputs. I'll move these wires yet again and hook this up to there and hook this up with the top two. So the top two are the selection for that radio button and the bottom two are the next. Of course, you can right click and grow these and add. You can make these switches really long to switch between 5, 6, 7, 8 different, in this part we have, supposedly 10 different signals, but you can generate other signals internally if you wanted to. Anyhow, so we got to hook up the oscillator. Well, the oscillator is mono, and we got stereo here, so we got to deal with this. Well, the easiest way, now we could, by the way, nothing stopping you from doing this. We have mixers and splitters. We can go to a splitter, single control, and slew or no slew, and get a splitter to split the signal. But that costs MIPS. And unless you need to do the volume control for it, which I don't hear. Well, actually I will be. I'll take that back. But I'd still rather do it discreetly. I'm going to get the Y because then it's two channels. I'm just going to do what's called a T connection. T connection is basically just telling the pointers, go get the data here. It's free. It's not. There's no MIPS involved. It just says for this input, and I'm going to wire this to the two inputs. For this input, get your data from this memory address. And then for this input, get your data from that same memory address. It's a free splitter. It's a free split. Now, for an oscillator, by the way, whenever you put an oscillator in, some of our new DSPs have a gain control on there, but I still rather have a slider if I can afford the MIPS. So I'm gonna put a volume control because these are on this one I'm okay with the no slew, single volume no slew. I don't care if it has a little bit of zipper noise. Because these oscillators, the signal sources, are at 0 dB FS for 24-bit signal. It's a max volume to go out to serial ports. So you want to be careful with that. It could hurt things. I'm going to hook it up. I'm going to turn it on. And I'm going to turn it down like about 30 dB because I don't want the tone that loud. And let's link compile download. Link compile down. Uh-oh. Unconnected pins. What the? Oh, I forgot to connect this side. Oops. Okay, try again. Link compile download. Yeah, you got to make all the connections. Oh, on that note, by the way, you have to connect all the inputs. Outputs you don't have to connect. So you can leave an extra output off and it won't complain. What it will complain about is an input because the compiler needs to know where do I get this? Where do I get the audio? Where do I get the data? For the output, it just puts the data in a memory location, and if nothing ever picks it up, it doesn't care. So, anyways, we're running here. I can switch it over to the oscillator, and voila, we got the oscillator running. We're looking good. Here's parameter changes. I can go in here and say no, I want it 1K, and it's 1K. That gets a little piercing. what you can see is in the capture window, I'm going to clear the capture window out. All the things I'm doing, you can see the commands going over. It's writing blocks to turn one switch off, the other one on. If I do a volume control, it's going to send a bunch of volume control commands out. So that's what the capture window is doing. It's capturing all the commands going out to the objects that are running in the DSP. This is what I mean by all we're doing is controlling the DSP at the moment. All the audio we're hearing is and all the processing is happening in the DSP. Now there's one other little thing you should add onto this project, and that is for testing purposes and for troubleshooting purposes. Because if nothing was happening, and this is especially true for spy communications, I2C, it will give you a warning, which I'll show you in a minute. It's a good thing to do on a first video. But all my projects I usually do this and keep it there if I have enough MIPS to do that. Go to the sources, DC input entry. So we're going to put up a DC cell, and this is like it, like it implies. You just put a number in, and it puts out a number, and that's called DC. It's also a constant too, so we use this for constants in your program. If you can ever use a constant rather than calculating something, use a constant. And we're going to do what's called a read back. Go to Basic DSP, DSP Functions. In here you'll see DSP Readback. Drag one of those in and connect it, the DC cell, directly to the readback. Now the purpose of the readback cell is to read back data that's being sent to it in whatever place you hook it up in the program. So it's your window into what's going on in a particular place. But remember, this is all sample based. So this whole flow gets calculated. It takes the input, one sample, calculates, does everything you're doing with that one sample, and then puts it out of the core. Every sample period, the whole program is run. But only one sample period. So if I put this in the audio chain, I'm going to get one sample at that moment I happen to click. And so keep that in mind. These meters, by the way, are just fancier readback cells. And sort of, kind of. The meter does have some, in the DSP, some RMS calculations that are going on, some averaging, and then you read it every 10 milliseconds or so to read the level that's more slowly moving. But still, it's basically a readback. And so let's link compile download. Link compile download. And okay, it took a little while. Now this has a number 1 in 5.23 format. So if I click read, it's going to come up with a number 1 in 5.19. Now this is important to know in this DSP. And the later DSPs we fixed this, but this early Sigma 100, the only way to do read back is with what's called a data capture cell, and it captures the accumulator at a certain point in the program counter and downloads that. That is a 24-bit read. The core is 28 bits. So there's 4 shy. So notice the DC cell says 5.23, but the readback says 5.19. That means the bottom 4 bits you do not see. So if you go to hex and you do the read as a hex, you're not going to see these bits are the top 24 bits. You won't see it. So you have to do a couple of multiplies. We'll show that in another project. But what's handy about this this thing to keep in your project is it will show you that you are communicating with your DSP properly. So I read a 1, it says 1. If I go to 2, because this DSP number is being held, this DC number is being held in the DSP, not in Sigma Studio. So when I do read, I'm reading into the DSP and saying, tell me what it is. And it's going to come back and say it's a 2 because I changed it to a 2. So this is a communications check, a SPI or I2C communications. Am I communicating with the part? So a lot of times if something's going wrong, that's a very handy first thing to do. Am I communicating? And what else do I really need to mention here on this first project? I think that's about it. Obviously, you go to Save As, you can save the project, and then recall it at any point. So I recommend you save this as your basic input-output oscillator. That's what I call it. And use this for future projects. It's very handy. And I guess that's enough for today. As soon as I say stop, I'll realize something I wanted to say, but we'll handle that in future projects. Thank you for listening.